Yeah, I think that's a great idea.
Cool. All right.
Cool.
Or maybe it's just like one of those.
There we go.
Okay, I think we're ready to go. Hi everyone, welcome back to Reality Check. This is gonna be our sixth episode, and today we're gonna be joined by Xue. Xue is a PhD student at George Mason University, studying computer science, with the focus on computer graphics. And today we're going to talk about one of Shay's research projects. It's called ScaffordSketch. It is a program used for industrial design drawing, and I'm gonna let her get into it. I don't want to butcher any of her what she wants to say. So Shay, I'm gonna hand it over to you.
Yeah, sure. So basically, it's a project that can help people, industrial designers, to draw very accurate 3D sketches, like in VR. So it's the main idea. It's the project is like this.
Gotcha. So what does Scaffold Sketch do differently from something like Fusion 360 or NX or a more traditional like CAD design software?
I think the the main difference is like as this group suggests, it's a tool like people can draw directly in VR. Traditional CAD tools like you have to like mostly you need to do it on the computer, and yeah, that's the biggest difference. And I guess the biggest benefit of doing VR is once you draw, like what you see is what you get, and you can directly get your 3D model. And I think that's really a nice benefit of doing VR. Yeah.
That's awesome. So when someone's using Scaffold Sketch, they have a head-mounted display, right? And then one or two hand controls. Is that
Yes.
right?
Yeah, yeah.
And then
Then yeah, they need to put a head-mount display like Oculus Quest, and yeah, they need the two controllers to draw and with other functions. Yeah.
that's really cool. If so then if someone is making a design, say they're like drawing a chair or yeah, say they're drawing a chair and um they like to make the legs they would hold down a button on the remote control and then like drag along like the contours of like the each leg and then they'd let go and then it would like does Scaffold Sketch like create a wireframe that comes out
Yes,
or
it creates a wireframe. And one different thing I want to like, one thing I want to mention is like, maybe just let me share the screen here. So
yeah, that'd be amazing, thanks.
yeah, so we can see the screen. So one thing is like why it's called a scaffold sketch is do you see the screen? Is can you see it?
Yeah, we can
So
see.
can you see my
It's
screen? Yes, yeah, it's a website of ScaffordSketch. So the main thing is like you need to draw the scaffold first, and then draw the like shape curves after. Yeah, that's why it's called a scaffold sketch.
That's really cool. So how does the scaffold help? Like I can imagine if you were an industrial like I haven't done industrial design, but like I can imagine it would help you to figure out like where to draw your 3D shape, like to make that
Yes,
structure ahead of time. How
yes,
does it help here?
yeah. Actually, I really want to show something. Like,
Yeah.
if you ever watched any videos of like a product designer draw, let me actually quickly share a video here. Like, so can you see the screen? Like I'm
Yep.
putting a
yep.
yeah. Let me just quick play this. Let's fast speed up. So if you ever seen like a product designers like industrial design as the title says, like one like traditional when product designers like want to draw like on pen paper to represent 3D drawings, what they do is like let me move it, put this a little bit faster. You can see when he wants to draw this boot, he didn't start out with like the boot, the actual shape of the boot, right? He draws this. It's kind of he draws this box first, right? Draw different plans first, and then in that, he's begin to draw the actual how the actual boot looks like, right? So, so we learned that like the industrial designers they prefer they have this workflow with pen and paper. So we learned this. So and used this in 3D. So they can like just have the same workflow like in the VR. So that's how the scaffold help the designers. It's kind of like they already get used to this way of drawing. And one heavy issue of drawing in VR is people cannot draw very accurate. But with scaffold, like because the scaffolds can help people draw more accurately in 2D, it can also like help people draw more accurately in 3D.
I saw the video on the website, and there's that the autocorrect feature.
Yes,
Is that what you were talking
yes.
about?
Um, yeah, I'm talking about like I want to point out two things first. The first thing is as this video shows, the industrial designers like they want to have the scaffold to guide their shape strokes or the actual objects uh, strokes. The first one is they want to have the scaffold, and the second thing is like I'm going to mention now, like the autocorrect, because you can see the scaffold lines are most straight lines, so we just use straight lines to stand for the scaffold. But you can see because in VR you cannot. It's quite different if you ever have drawn in VR. It's quite different. Like you cannot be that accurate. Like if you want two lines to intersection at this point, you might feel it's already like intersection at one viewpoint. But if you change to another viewpoint, you will find that actually you missed that. So that's where the place we add autocorrect, and that's kind of the main contribution of it. Yeah.
That's really cool. So in order to so that it's kind of it sounds sort of like it's analogous to a snap feature, like in
Yes,
more
yes,
traditional industrial design.
yeah, exactly. Um, like I there is a paper about how people cannot draw very accurate. There is a paper like saying how people drawing bad in VR. Like they have done several experiments like because of laking of, as you can imagine, because laking of physical surface, like it's very hard. Like for example, if I just want to draw a line, you can see even though my arm is like kind of like this, but actually it's kind of like this is like the circle. It's kind of like a arc because I
Right.
cannot draw. And especially if you without the surface, if you ever try to draw a perfect line in VR, you would find that's almost impossible because you cannot achieve that high motor control. It's something like this.
Yeah, even drawing a straight line on paper, there's always some unavoidable amount of error.
Yeah, yeah, exactly. So the beautification and snapping has been non-used in 2D, so it's kind of also borrowing this in VR. But we add an extra step is like we learned from the industrial designer. We found they enjoy drawing the scaffolds first, and after once we have the scaffold, you can see this chair. You can see the chair is bounded by the scaffold. So, and the intersections are like mostly tangent. So they can. So you can see. So you can see this is the input scaffold, and based on their relationship, we autocorrect to a very nice cuboid with some straight lines, and this is just the user input curves. You can see it's not very smooth, right?
Looks
That's
like me
where
drawing.
we add, yeah, autocorrect. So that's the result.
So the scaffold is the scaffold used in the autocorrect as well?
Yes, definitely. It's kind of like a guidance because without the scaffold, you don't know like which direction. Without the scaffold, for example, if you just look at this line, so even without the scaffold, you cannot know for sure this line or this point should be stay here. So the scaffold is so first the scaffold can serve as a visual guidance. Like people can see the scaffold, so they can visually see it, so it can better use as a bound. The second is the directions of the scaffold can be used to guide the curve directions, and some like key positions can be used. Yeah, this scaffold like is quite important. It has like a very important content role in the beautification.
So you mentioned that you interviewed one or more industrial designers as part of your research process.
Yes.
That's cool. What sorts of designers did you interview?
Like one of our co-author is teaches like industrial design in a university, so that is really great resources, and
Wow.
yeah, yeah, that's really cool. So he said that, like actually join the scaffolds and then join the shift strokes is kind of a traditional way. It's actually called analytic drawing. It's kind of a traditional way taught in universities, taught to the product designers. So I think this is like a great tool that people can directly, like anyone who knows this technique can directly use.
So I guess like
Yeah.
the kind of like the value proposition of Scaffold Sketch as opposed to like a program like 3D Blender is that you have that it allows like for that intermediate step, you know, like where you can sketch before you can actually before you put everything together.
Yes, yes, yeah, yes. Um, Let me. Can you see this? So actually, this is the user input. Can you see it? Like
Yes.
Yeah,
yeah.
now we can. No.
So you can see. Can you see or
Yeah, we can.
not? Okay, cool, cool. So actually, you can see it. Like this is. Let me get. So this is what the. Let me put the scaffold here. So you can see even with this scaffold, the curve is not very right. It's not as smooth as if without autocorrect, its output is like this. And even the user try to like draw good, like, but it's still like the curve is not that smooth. So even they can see this as a guidance. So that's where we
Oh wow.
add the autocorrect. So the final result could be really smooth, right? So that's yeah, yeah.
It looked like you had sliders that had to do with radii. Is that for like filtering out small wiggles and like other noisy movements, or is that something else?
Sorry, what?
there were some sliders that had to do with radii. I'm getting
no,
curious
no.
about
This
like
is
noise filtering. Is that? Yeah, go ahead. Sorry.
no. This is like how you can adjust, like
Oh,
the radius of the strokes. Yeah, this is just
got it.
if you can make.
Just like kind of like to increase the stroke size.
Yes, yes. It's just increase the stroke size. Oh, you mean, yeah? I think you also raised a very interesting question, like how to do the smooth, right? Like the you mentioned about noise filtering because like
Yeah.
we can say just yeah. So that's also we should that's also one thing we contribute to the scaffolds. Like like we would calculate like this point may intersects with the scaffolds and their direction is almost the same. So that's tangent to this point, and also this point is intersects and tangent, and this point maybe also intersects and tangent. So that's where the scaffolds played a like quite important. So we because we have this point and direction, this point and direction. So that's the information we used to smooth the curve. So we didn't do any like noise filtering for it because we can just use those information and beautify it. Yeah, and
Wow.
smooth it.
So the scaffold, like using the scaffold, is like the only like resource or reference that was needed to get to that level of smoothness. That's awesome.
Yes.
I
Yeah,
I had
exactly.
thought when I saw the output, I thought like, oh, there must also be like some noise filtering out there, like maybe maybe you're changing the lines so that uh there can't ever be like curvature below some like minimum radius, so that like small wiggles go away. But no, you managed to get away. You managed to get rid of those small wiggles with just the scaffold and just like that's really cool.
And
So
I
that's
was
incredibly
thinking like
useful.
I was like over here like, oh, like is she using like ML to like smooth out the smooth out the lines? I'm like, no, like there's a much simpler solution.
Yeah. And one other thing I really like about scaffolds, like about our project. Now I'm trying to like sell my project just for you.
Go
Please,
ahead. This is your platform. Yeah.
please pitch. Yeah.
Yeah, another thing I really like about like our way of scaffolds. So just the example you just saw is a chair, right? Let me pull out another example for you. Like because we only use these simple lines as scaffolds. Like some people might I got like some people saying like why don't you just start with the cuboid because that seems more it's more convenient. But another thing I really like is people can create their own people can create the scaffolds like for any scaffolds they want. So so here is also another like user study results. Like I don't know like industrial designers build scaffolds like this way. It's like I don't know like how did he do it. Like it's kind of amazing to me. Like he just used this and draw this like at least a very nice shoe for me. So it's kind of like I really like that people can draw any scaffolds like they want, not only limited to those like keyboards or like some primitives. Yeah.
Yeah, I can't imagine the difficulty of making like effectively a mesh just in your head and putting that onto paper or putting that into a 3D VR sketch. That's that takes so much skill.
Yeah.
But it sounds like, not only is this useful to an industrial designer, it sounds like it could also be useful to like a layperson who wants to like get into CAD and maybe wants to like have a more intuitive workflow. Is that because it seems to me like you know you could make a relatively simple scaffold and then use that to sketch in air, and like you don't need any pre-training for that, and it seems to me like your tool would like fully support someone who's just getting into CAD and like wants to start out drawing. It it seems that way. Is that right?
Yeah. Yeah, I just present this paper at a conference. I got some like really interesting talks with someone I met at the conference. Like, yeah, yes, I think like for anyone who have know a little bit about analytic drawing, or even like because I was building this project in the process, I also tried to create a lot of different shapes. Like, yeah, I think like for anyone who learn a little bit of this can use this to create some like can use it to create the models they want. But currently there are still some limitations because the output is just curve networks. Like, it's just 3D curves in the air.
Right.
So if you want to turn it into a mesh, you need to use some extra tools. Like, I have tried. There are existing algorithms to do this, but currently the direct output is not just a 3D mesh. So that's one, like, you cannot. It's like after you draw something, you can export it, but it's just a 3D curved network. You cannot. It's not a mesh.
Right.
So, yeah. On the other hand, like you mentioned, like well, like people who is, yeah, I know I haven't used CAD tools a lot myself. Like, maybe I don't know that area much. Like, I don't know, like if you want to be proficient in your CAD tools, how many hours you will devote to it, like how complicated or how easy it is to use some CAD tool to build meshes. Like, on the other hand, if you could just do it, if it's like a really simple mesh, if you could just do it, I think that will benefit a lot of people. But currently, I think in current, like, we know there are a lot of VR tools in the market, right? Like, such as Tilt Brush, and I don't know whether you have tried that any of those before, Gravity Sketch. But I don't think that has influenced much of the product designer's workflow. I think still many people still like prefer to like do some prototype first with pen and paper, and then use the CAD tools to like make it a 3D model. I don't know whether you have tried any VR drawing apps before.
I used it wasn't Tilt Brush, but a year ago I used something that was on Steam. I can get the name of it. But don't wait on me. So for a professional industrial designer, this could go into their workflow as like a replacement for 2D sketching, where like they can have this wireframe that comes out of your tool as a reference for when they're making like a solid object like that isn't a wireframe. Is that right?
Yeah, yeah, yes, exactly. I hope this can like help them and change their workflow. But currently, people still heavily like use the like CAD tools. Maybe like during the conference, we also kind of have this discussion, like on which day, like how many years later will like VR drawing like really change the workflow maybe of some industrial designers, like because currently people are still using like CAD tools, but will it be like 20 years later people were using this kind of tools in their workflow? Because it would be interesting to see, because like um, once they know the analytical drawing, they can use this technique, and I think it can like help them like it can help them like in some way that they don't have the burden to learn more about CAD tools and use CAD tools. Yeah.
Mm-hmm.
Yeah, and provide like a 3D aspect to their wireframes.
Yeah.
Did you have any plans to like kind of implement this in AR?
Currently, no, I'm not that familiar with AI.
Mm-hmm.
Do you like? I know AI is kind of like, and of course there are some difficulties I have seen. So just so AI is more like augmented reality, right? You can
Yeah.
also see the object when you put the headset or some, or just like normally how do people do AR? Do they have also to put on headset or just use phone?
Usually they do one of two different ways. one way is their head-mounted display has front-facing cameras, and then the display shows the user live video feed of their environment with virtual content overlaid, like placed into it. And then the other way is to have the head-mounted display be transparent so that the user is actually physically observing the outside, not like a recording of it. And then the head-mounted display puts in other content, sometimes through like lasers and double mirrors and stuff like that, um, in order to like put it in the scene and also like not obstruct the screen, which needs to be clear. So that yeah, two different ways: video pass through and like just having a transparent display.
Okay, so I think in one way it can be easily extended to VR. Like if you want to draw some object, definitely this can be easily extended to VR. But on the other aspect, since because in AR we can see the environment. For example, if I already have like something, maybe if I already have a desk here and I want to do some design of this desk, or I want to do like some special desk design, that would be like that would be kind of problematic because in that way the user have to draw the scaffold of the disk, right? If there is a way to automatically create the scaffold of the already existing disk, then I think that would be very valuable because based on that the user can like draw easily and accurately for the like for any shape strokes for any actual design he want to do. Yeah.
That makes sense.
Yeah.
A lot of the time in industrial design, there's a drawing that needs to come out at the end, where like you have documentation and like the final 3D part is shown from multiple angles, like an orthographic projection, and then you've got like dimensions on there and so on. Do you know if there are tools out there that let you like take a 3D wireframe sketch and like annotate it? Not for like not for a final product, because I know that the place that you want this to be in the workflow is like preliminary to traditional CAD. But like, are there ways that 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 exist where like a user can take a wireframe model and like mark it up with like, I don't know, place pins in the air and like put like little details attached to them? I don't think this is a very good question.
No. I think there are definitely such tools because during this, during I do this, I read not I read several papers about like there are already, I know there are some existing tools to help you drawing AR, like because as I mentioned, the lack of no surface is the reason that makes mid air drawing not accurate. I know there is a tool called system bio sketch that is AR based, that you can define a surface and then draw on a tablet, and the curves you draw on the tablet will be projected on that surface. In that way, it can, like for example, if you want to decorate anything in the, it's kind of mixed reality, I would say it's like this.
Yeah.
Like if you want to draw something like attached to your desk or that, yeah, there is some existing similar work. I don't know whether it's like quite what you wanted, but it's kind of like similar.
Gotcha. That's really cool. There's also someone in the creativity and graphics lab who has done work in like cleaning up two-dimensional sketches,
Oh yeah, I know
right?
him.
Gotcha.
Yeah.
It's it seems like there's like some parallels between your work. Like they're both about taking like a raw sketch and then improving the quality of the output, right? But he doesn't use a scaffold, right? He just
Yeah,
yeah.
yes. So I would say there are because what he takes is the I would say there are several stages of sketching of drawing. Like in the initial, I can show you continue show you the video. Just I haven't finished. You can see
Yeah,
in
yes,
the
please.
yeah in the let me share my screen again. So cancel. Okay. So you can see
Yeah.
you can see like in the initial, like as we just said, he used this scaffold a lot, right? But once he has the general shape of this foot, look at what he will do the next step. See what he did? He just yeah, and he want use it like as and then draw like what is this for? I don't know what is this technique exactly called for him for the designers, but you can see
He's basically tracing.
yes, exactly. Yeah. Yeah. Like once he has all those things, he want to, if he kind of want a cleaner version of the thing he draw, he will like tracing on it. But in the end, even the tracing cannot create like very. This is a very, but it's not a, like for computer graphics for he or she like so this place is kind of needs to clean, right? Because it
Yeah.
may be just a single stroke. Yeah, yeah. So it's kind of like different, like the input of yeah, it's kind of different. And even I know his work. Like even the sketches he collected from some artists, they still have this scaffold layer. Just like very light scaffold layer. Like if you check on the his project page, you can see there are all kinds of different sketches, and actually for some sketches there is still a scaffold layer. Yeah.
That's awesome.
Yeah.
So what's next for this project? Is it how much? I don't know. I forget at what point are you in your PhD, and is this your thesis project?
No, this is just my third year. I just begin my third year. It's kind of like finish the course, so still have some course left. And yeah, so as for what is the future for this project, definitely there's a lot of future work that I can continue doing with this project. And one thing you mentioned is like currently it's just wireframe. If we could surface it, that would be really nice, right? So that's some possibilities in the future. And also, if I just for the previous video we have shown, like in the booty example, there are some like strokes for the decoration, or maybe we can think of a way like doing the texture for it, like also nice and smooth. So that would be really very helpful. So I think there are a lot of like possible directions, possible future work for ScaffordSketch, and yeah.
It seems like it has a lot of places it could go, and like a lot of really exciting things that you could do with it in the future.
Yes, yes, I think so. I think so. And I think there's definitely some like another thing. I think like bursts of paper. I don't know whether there are people doing this. If not, I hope there are someone doing this, but not me. Because let me tell you about this. I think a thing like really worth doing is it's like this threshold. Like because when we are doing the autocorrect, when we are doing the beautification, we kind of like take into account because as I just showed you, like when the curve intersects with the scaffold line, we need to consider like how close do we consider intersects because you know it cannot be that accurate. It's
Yeah.
like even for pen and paper. No, I just take out my sketchbook. Even for pen and paper, if you want to draw some a circle, like sometimes you will go past it, right? Sometimes
Right.
you cannot close it perfectly. Like in this case, if I want to have a closed cycle, I will consider how close there. So I think if a person, and in 3D it's different, that your view direction, like if you standing in this view direction, also plays an important role. If there's someone could do this, like personalize all these thresholds, like doing several tests, like marrying, like measure all the things, like people, how well people draw, if they are drawing in this direction versus they are drawing, like I think if there's someone could do this, that would be great. If someone could design some experiments to personalize the threshold, that would be great. Yeah,
Mm-hmm.
but this is so hardworking and hard to design. So I personally I would not do this, but I really wish there could be some work about this.
Yeah, that
Yeah.
sounds like it could be a really useful quality of life feature. Like not one that necessarily, increases the number of things that can be done with ScaffordSketch, but definitely makes it smoother to use. But yeah, that sounds like so much work.
Yes, exactly. As you
Yeah.
mentioned, this may not only like limited to R. It's kind of like a VR collaboration, something like that. To it also could be used in other scenarios, but I think it's just so hard to design such an experiment. So I don't. So I hope someone could do this.
Well, we actually have a question. So
Yo.
Jack Dawes said that I saw that Adobe contributed to the paper, and he was asking if they're considering using this in one of their products.
This is a project. Um, Me collaborate with my advisor, and also I for this project I have done a summer internship as Adobe. I don't think currently I would say I don't know, because if they did, that is totally confidential. I don't know whether they are going to use this, but I get feedbacks, like for some people who have used during the study, for someone who have used the Gravity Sketch, they said they wish Gravity Sketch also have this scaffold 9 function in them. So I think it will be great if some like commercial products could like embed this, because for me, for for research project, the functions are quite limited. Even we have this scaffold and shape stroke and all the beautification, but for a big company, definitely I believe they can do so much more there. I wish someone could. I wish they could use this. They could use this. Yeah.
Yeah, I mean, there seems like a lot of value.
Yeah.
Yeah. Maybe
Hope
you'll hear back from them sometime soon.
hope they hope they do like think the same as you do and as we do.
Ryan, you're kind of in your element. Does this take you back to your engineering days?
This does take me back to my mechanical engineering day. Yeah, I'm a recent transfer into computer science. I'm a first-year master's student, and my bachelor's was mechanical engineering. So I spent a lot of time um, in engineering CAD tools like SolidWorks and Unigraphics NX, and recently switched to Fusion 360 for like some other like less industry focused stuff. Um, I remember that across the different like CAD programs I've used, um, they've had very different learning curves from one another. Like, and also the problem is, if you're working at like an organization, if you're working at like a company, they probably have a license for like one for one
Yeah.
program, or at least for a particular job. They have one program rather than like paying two subscriptions for however many employees, which could make an industrial designer land in a sticky situation. Like if I was working at a company and I learned, oh yeah, we use SolidWorks. SolidWorks and I are not friends. Every time that I've tried to use SolidWorks, it's felt like swimming through gravel. Like everything is wrong. At least against my intuition. Like nothing. Like these are all like workflow incompatibilities between me and SolidWorks. I'm a novice and I'm in no place to judge them. Um, uh, and it would have been, I think, in that situation so much nicer to have a tool that has an easier learning curve. And I think that for something like generating 3D wireframes, sketching in VR is maybe as intuitive as it gets. And the fact that you can then support that process and take the output that is inherently messy because you're drawing in 3D, and because you don't have like the natural damping of your hand against paper to help you stay on course, like you're just in the air, your hand naturally shakes when it's in the air and so on. The fact that you can take an intuitively made sketch like that and clean it up so that it's like really useful for an industrial designer, for like a person who's doing this professionally, is amazing. And I certainly hope that Adobe gets back to you. This seems like
Thank you.
something that has so much potential to me, to someone who's not that familiar with this. Yeah,
Thank you.
yeah.
Yeah. Adobe, I hope you're tuning in. But yeah, no, thank you so much, Shay, for joining us today. We're out of time, but is there anything else that you have going on that you'd want our viewers to know about?
And it doesn't have to be related to this. Obviously, it can be. Just anything at all that you want to plug.
I hope that one day I can come back and join you with my future work on ScaffordSketch. Maybe make it more a better system, like with more functions, with more like not only the things I mentioned above, but with more interesting functions like we learned from product designers or we learned from yeah.
That sounds like it could be fun. Like maybe our viewer base would be really interested in watching, the development of a VR research project over time, and the decisions that you make, and like the obstacles that you run into, and the new features that you're working on. That, to me, could be really cool.
Yeah, I'm already down.
We'll make a point of reaching back out to you sometime.
Yeah.
Next time when I publish a paper, I will go with like if I still in GMU, I will go with both of you.
And even if you take your talents elsewhere, yeah, feel free. Yeah, we love having you on the show.
All
Um,
right.
but yeah, thank you so much, Shay. And thank you all for tuning in. Remember to smash that follow button, and we'll see you next time.
Thank you,
Thank you.
Shay.
Thanks, everyone.
Okay.